And we are recording now. So welcome everyone to this virtual interim meeting of the core working group. My name is Marco Tiloca, my co-chair is Jaime Jimenez. And as usual, this is an official ITF meeting, so the note well applies, and be sure to be familiar with it if you're not already. It is not just about IPR and patents, it's also about code of conduct. So as usual, be nice with each other. And the agenda for today is about two documents on group communication. We'll spend most of the time for the session actually for the group com-bis documents with updates and open points for discussion. And the second document is instead the companion group com proxy, focused on setups involving proxies, and again on ongoing work and some open points that were triggered by activities in group com-bis and on other related documents. Does anyone want to bash the agenda for today or propose more points to discuss?
I've taken the liberty of adding something to the AOB, but I'll talk about that later, so nothing more to say here.
Sure. And before we actually start, a question to you, Christian, actually, any status update on the echo request tag document?
I'm working through the list, so the kind of trying to have slotted in between other things that are also urgent right now. What would help, Göran, as you asked, if you could have a look at the point-to-point responses that I'm preparing in parallel to editing in things. But I don't see any kind of there's no large things. It's just things that need to be done.
Okay, so is it like as you go, or is it something some specific thing?
It's as we go. Basically, all the issues are tracked. It's the same way I did it with the resource directory. There's a file in the GitHub repo where all the comments are tracked, and they basically, as I solve things in the document, I also add the responses there, or if things are already resolved or just need a response, then those are already in there.
Okay, so I'll have a look now.
Thanks.
Thank you. More and more people are eager to see echo request tag to the RSC.
Yes, I know the cluster is slightly overdue.
Thank you. Okay, then we can go on with the first document, group com-bis, and Esko will present. You just tell me when to change slide.
Okay, that's perfect. Thank you. So I hope the audio will work well. So this is the first time I'm using a new USB hub with speaker. So let's see if there are any complaints. Let me know. So now the progress in group this. Okay, let's move on to the next slide. Yeah, this is the recap, which hasn't changed. Is there anybody who needs the recap of this document here? Some details. If not, we just continue with this one. Go to the next slide. Yeah, so we've been doing edits on this document, and a part of the content has moved out. So yeah, we have basically caching model at proxy. Yeah, so what we decided is to move proxy-related things to the group com proxy document. You can find that content now in the editor's copy that is on GitLab. It's also shown below. And also specifically the topic of response revalidation between client and proxy is also moved out from the current draft to also go to the group proxy draft. So the goal was to keep group com-bis a bit limited in scope, don't add too many new things there. Of course, you still have the caching and revalidation between clients and servers for group communication, still in group com-bis. Okay, we'll learn some more details about these things in the presentation. So I'll go to the next slide, please. Yeah, so we got a review. It's already 2 months ago. It was from John. And I made recently a response to that and also created a couple of new issues to take up the things that I think we need to improve indeed in the draft. So you can see here the links to the mail discussion. Also the new GitHub issues that were made. Yeah, so the first one is to provide more detail of what exactly is updated or replaced in documents that we update, like org RFC, for example, 252. So what I propose is to have a new section on that, so that combines basically all the changes that we make, or updates, additions, or replacements. Have that in one place. Yeah, issue 21 was I found an interesting one because we limited always the scope to be over IP as the transport protocol. The proposal from John was, well, why not also potentially include other transports that can use multicast, broadcast, groupcast, or geocast, all kinds of protocols where multiple nodes are targeted. Even unicast could be scope perhaps, but that's to be seen. Yeah, my initial analysis on that was, well, it's interesting. It should be doable because many of the things are not necessarily UDP specific. But we have to look if that's possible without making it a mess. Something that requires a little bit of study, and that's the issue 21. See if that's possible. Yeah, number 22 was about security, so more considerations about application attacks. I actually sent back also a question to the mailing list on that. So that's require a little bit of further input. Maybe we have to consider the amplification attacks when group or score security is used, and also when it's not used. Okay, so this is the last, the open point mentioned at the bottom. So yeah, so we require, I think, a little bit of feedback to make progress, maybe from John or maybe from others who want to chime in. So what would be the relevant attack scenarios for example, spoofing messages that are protected with group or score, using a different source IP address and replaying the packet again. Okay, any questions so far?
So what, I haven't read this latest updates. What is written today about these attacks? Is there a list of different attacks scenarios currently, or is there nothing there? What is included now, as of now?
Well, what I know, it is mentioned. I think it points to score draft basically, and says that, well, with group of score you can you can mitigate this type of attacks. I think the request was to have more detail about that, and also warn that group of score does not solve all the problems.
Yeah.
Marco, do you know if there's a list of attacks?
No, I just wonder what source we should have for, because that's, I mean, there certainly are these kind of threat analysis made for different settings. I wonder if we could use some source there. I don't have anything at the top of my head, but I don't think we need to sort of start from scratch. We could look a little bit at, find some existing analysis that has been done, and then, I mean, in particular looking at multicast, I suppose, and see what is applicable, and where does Drupal's core provide a solution and where does it not? So I think I mean, you're basically what you said, but I just wondered what is done so far in this setting.
I think at a high level, John wanted to cover a group scenario with this kind of attacks also in his new draft co-op attacks. I understand he hasn't done it yet, but he's interested in doing so. So at some point we can connect the two documents.
Okay, yeah, that would be good.
Here for Group Combis, I think he wants to not give false hopes to the reader that just because you have Drupal's core, possibly together with Echo, you are just solving this all together.
Yeah, that's the point. So if you use the Echo option, then you still have a group service potentially is sending something back, so that you get the amplification effect. So the response packet is then quite small. Still, yeah, you get amplification. I think that was the idea, to make that also explicit. Yeah, add that consideration. Yeah, then my response was, well, if you have this IP spoofing scenario, then the servers will not even respond. In my scenario, at least, so that was why this, yeah, gave a bit of a question. So why would servers respond in any case to the spoofed backup, because they would normally not respond to it. But yeah, there might be some scenarios where it does happen. So it's good to clarify. All right. Should we go to the next one? Yeah, we also have open Github issues. So this is listing those. A minor thing that we improved is for number 15. So we moved around some introduction text of section 5. This was quite big and deserved an own section 5.1. You can also refer to it in this case. So brought some more structure, section structure to there. Number 12 was maybe more like a question. Okay, can we actually refer to examples of an RFC if we also obsolete that RFC? Some discussion back and forth. And turns out, yeah, that should be possible. To make it clear that this is an obsoleted RFC, so use the past tense to it. We write things like RFC showed or RFC defined to give a little bit emphasis on the fact that that one's obsoleted. But we still point to the examples, and these are still, yeah, let's say valid. We don't want to reproduce all the exact examples here in this document. Number 14 was a question that came up. So what is the interaction between observe option and no response option? So typically with doing an observe, you expect, of course, to get responses back from the servers. And with the no response option, at the same time, you can say to the server, please don't send me the response of a certain class. So we clarified this a bit. So the idea was basically that normally if an observer is added at a server, then that server, yeah, should actually send a response to the client that was just added. That's the default behavior. It also signals to the client that, okay, this serve request was successful. And that's why it should normally not suppress the response. But user can still override this by including a specific no response option. So that will basically override the default response suppression, as is already the case. So this can be combined, and not all combinations would make sense, of course, but you can do it as a user. I think there are some potential use cases of this, as Marco mentioned, that could be reasons to combine these two options in very specific use cases. We also point to this document at the bottom, so the core clarifications document, which could have maybe more general ideas about interaction of these two options, especially also in unicast situations, for example. We are not going into too much detail on just saying that you can use them together, these options. And now the question to the working group, is this okay? Like this?
I'm just a bit curious, Christian. I'm just a bit curious as to why would this behave any different than regular responses, especially given that the observed request can be a confirmable request, so the client would get an ACK back, and like with all other no response cases, if there's an ACK but nothing else, it's obviously it probably went through.
Requests are non-confirmable, at least in the group case.
Oh, sorry, I slipped out of the context. My apologies. Thank you.
If you go one by one, sure, you can still have them confirmable too.
Yeah, sure. Stupid me. Sorry.
Yeah, it's one of the reasons for the should respond. Okay, any more comments on this or disagreements? Well, we're not in a large group this time, so expect too many. Okay, we can maybe move on to the next slide then.
Mm-hmm.
So further Github issues, I'll start with number 16. Top, so this was done and addressed. So there's also a recommendation to have size-based filtering, at least possible in border router devices or egress devices that take traffic, not cast traffic, into a 6-LoWPAN network. Because from, let's say from things like earlier simulations that I've done many years ago, you see that fragmented multicast traffic is normally very bad for the performance. So if nodes have to reassemble the 6-LoWPAN layer many fragments and then create a multicast IP packets from that, and you can't expect very good performance. So it's kind of normal that device that allows you multicast traffic onto the 6-LoWPAN network will have some filtering, and one of these things can be size-based filtering. So this is recommended. So we're not saying anything about exactly how it should be set, but that's good and that this exists. And it's also for application purposes on 6-LoWPAN networks, then usually for multicast also very small packets are used in combination with co-op. So just relatively small payloads that it would fit in a single radio frame. That's, you could say, the best practice there. Yeah, so number 17, Jira had a little bit of discussion on that issue. So the question was, what are actually valid cases of having a forward and a reverse proxy with either end-to-end security or what I called two-leg security. So that's not end-to-end security, but just that two legs individually protected, basically. And this is a topic that you could say, well, more or less belongs to the new draft group on proxy. And I think so too. But yeah, my proposal was still at a high level to include something about it in this draft, just to mention what are the valid combinations there. So you can, for example, forward proxy combined with end-to-end security, or you could have a forward proxy case where there's these two legs of security. So an example could be one being DTLS to reach the proxy itself. The proxy completely independent way uses group or score to talk to the group. Right, we have this type of security, so it's not end-to-end. It's actually a lot of trust in the proxy. You trust it similar to the client itself, let's say. It's key material to operate on the groups. The proposal is now to add a little bit of text here in this section 5.3, just to mention what are valid combinations. And it could also include references to the group proxy draft here to point to the maybe more details that we specify there. So yeah, there was the discussion part there. Is so if one thinks that certain combinations make sense or do not make sense, then let us know. Useful input. All right, and then the final one here, number 19, was the consideration how to handle queue block options, because we talk about block options, but since then the queue block options are also added. And there we just take on the text basically that was already defined in queue block, so it's not to be used in all the cards requests, so the servers must also ignore this. And that we've added to the draft editor's copy. So any questions on this? If not, we can maybe move to the next one. We don't have topics to discuss in detail. No? Okay, then I think we can move to the next slide. Yeah, thanks. So this is a lot of text here. So we have it's part of issue number 11 about the rules of caching with origin clients. There's been quite some discussion there. So in general, problem there is if you are a client, you can basically cache the results of the previous group request. That's no problem. But what if you want to do a new request? Can you serve that from cache, partly or entirely or not? So we need to clarify that. Now the problem there is if you want to serve the request fully from cache, then normally you can't do that because you don't know if maybe a new member in the meantime joined the group. So the model typically is that new members can join the group at any time. So if you then serve the request entirely from a cache, then you miss those new group members. So that's why some rules are needed here. And now we need editor's copy. I proposed a simple solution. So that in all cases the group request needs to be sent out. So you can serve from cache as defined in RFC 7252, but you also need to send out the request because new servers could have joined in the meantime. But if the client knows for sure that it has fresh responses from each group member from all group servers, then it can serve, of course, entirely from cache. But that it can only do when it knows the group, so it knows all the members that are part of the group. It's kind of an exception case, so you can apply that. I don't think there's much else you can do there.
This is the co-op group now, not the security group. Or
this is let's see, the co-op group. Yes.
Yes.
Does it matter in terms of the security group? I mean, if you add group or score to this, does this change, or is it still the co-op group that it determines?
Yeah, the co-op group is basically where the request goes to. So these are you could say the group members that matter in this case. If somebody joins security group but not the co-op group, then that member would not get the request in any case.
Right.
So you need to know about the other servers not necessarily about other clients that can be in the same security group.
Okay.
Yeah, I think for the proxy case, we also have something similar. So we can say that the proxy as a client also doesn't know always when group members are added. And then in group proxy, I believe we have some text for that that can basically say, okay, if the proxy is in a position that it knows all the new members that are joining, for example, if it's a border router that receives all the group join requests, joining the call group, then can just keep track of all the members. It's network. But in that case, that helps to make those decisions. But yeah, this is saying that, well, unless you have that kind of knowledge, you can only basically, the only thing you can do is send out the group request again, just to catch, yeah, maybe new servers that have joined in the meantime. Could also be based on application level knowledge. If you know that new group members only join at midnight or so, yeah, you can use that knowledge, of course. But still in that case, yeah, kind of you need to be sure that you have fresh responses from every group member. Okay, and then the last bullet of the slide was also about number 11, so the aspect of placement of these caching features, functions. So we have caching at proxies, and that's all of that is now moved to proxy, at least, yeah, for the details. And the caching at origin clients, that's what we now discuss in GroupCom this. Yeah, the same is for the revalidation. So if there's a proxy involved, we put it in the GroupCom proxy draft. The last point is basically about revalidation. So there was an open question for a while. So how do we do revalidation? So client wants to revalidate responses with the number of servers. So how does he do that? And the current proposal we have, also included in the editor's copy text, is for discussion, is using the ETag option. I think we have a next slide about that. So, have a look at the next slide to see what's there. Yeah. So that's basically number 2 of the numbered list here. What I mentioned, so using the ETag option. So the design we have there is that in GroupCom this, we would like to have a final solution for that. So clients can do revalidation with the group of service. And once we have that solution, we can also reuse that, hopefully, in the GroupCom proxy draft. So the proxy can use the exact same mechanism to keep it simple. And yeah, so what we do in this document, the GroupCom this, is now write option 2 in there, so use ETag. But of course, there are also other possibilities. So just to review this numbered list, we have also defined a multi-ETag option that was proposed in this version 3. And that's actually similar to ETag, only there's some information in there coding an identity of the specific server that is being targeted. Number 2 is use the original ETag option, and there will be some more slides coming up about that, how we do that. Number 3 and 4 were also some suggestions that were made in the discussion. So basically have a co-op option, which is a single aggregated tag. I don't know exactly what that was again about, so ask a question if he still remembers. Number 4 was a time-based application. Question is based on block time. So maybe Christian, if you recall what this number 3 was about.
So I do remember what number 3 was about. It was basically a way of compressing down the multi-ETag so that at least we don't have to send the addresses around. We still have a bit more granularity of kind of how likely we want ETag, we want kind of reducing the information to accept some likelihood of not getting a particular change. But that, like the multi-ETag, probably depends on a very strong use case based on which we could sharpen this, because if it's sending addresses around in ETags and kind of sending so many ETags around that it makes sense for an application makes those requests really large, and we had that issue just before. I do remember what this is. It is a form of compression, but I don't think that we have a good use case for this, neither for number one. Number four would be something like if not modified within the last so and so many seconds, which might make sense.
Yeah, that was, I think, a similar reason we had there. So there's potential use cases, but no strong use case we see at the moment. It's not that clear where it will exactly be used for. So it was, I think, the motivation also to go for option 2. So use something that's already there. It's also backwards compatible and quite simple to use. To define anything, well, not much new for it. The option can be used. So so in a sense, these options are somewhat similar, 1, 2, and 3, but minor differences, then I would say. Okay, but that's at least for further review and discussion. So far we have selected 2 here. Okay, and then maybe let's go to the next slide. Have a bit of recap of the multi-ETag option. So that's like ETag, but only intended for group requests. There's basically one instance per server in a group you want to revalidate against. So if there's 3 of these servers, for example, you want to revalidate with, then 3 multi-ETag options in the request. And each option contains basically a number of CBOR encoded sequence of ETag values. And for the rest, these ETags work like ETag. All right, this is only a bit of recap, so we'll move to the next one. Discussion. Slide, please.
You should see slide 10 now, right?
Yeah, 10 is okay. Yeah, sorry. Maybe it was a bit slow. It's okay. So these are the options 1, 2, 3, 4 are listed. The multi-ETag was on the previous slide. Now there's a little bit more explanation about the ETag option. What do we do? Well, it's used as normal. The idea is that normally a server would not use ETag for multicast request and then a response. But in this case, what we specify is it can do that. And if it does that, it's recommended to embed a compact server-specific ID into the ETag value. So this could be something like application group specific, or maybe hash if it wants to, or well, anything the server likes. It should be chosen in such a way that there's low probability of conflict with other servers that also select this server-specific ID. So it's more or less left up to the server how to create this. And now the client gets a little bit more work to do. So we assume in this case the client is typically a less constrained device. That's, for example, pulling information from constrained servers. The client can do a little bit more homework, so it can also look at if servers return back ETags. It can look at the values, compare the values, and also see if there are conflicts in values. So that means different servers use the exact same ETag. In that case, it knows, I cannot revalidate using that ETag, or at least, there will be potential conflict in that case. that's a bit of extra burden to the client to use these E-tags in a smart way. The nice thing of this is that if you have legacy servers that follow RFC 7252, that are not aware of this new E-tag use, they will just ignore the option because it's not specified to be not allowed for multicast, so they will ignore that as an elected option, which is still okay. So you get a little bit of extra traffic, but that's fine. So that's the text we have proposed in the editor's copy. Keep things simple and reuse what we have. And now the question is, do we want to explore the options 3 and 4 further? So as Christian said, 3 is maybe similar to 1, and we need a good use case for that. What about number 4? I'm personally happy with the E-tag option at this moment. We still have to see how that can be used or will be used in the future.
Sorry, I'm a little bit lost in the logic here. So we had the 4 alternatives on the previous slide, and here are 4 sort of solutions embedding these. Is that and you are proposing the second here?
Yeah, so these are the same 4 options.
Yeah.
Yeah, and the second one we have integrated into the text.
But the first one as well, the multi-ETag is still there.
Yeah, but it has been moved into an appendix at this copy with the idea that it will be removed from the draft.
Okay.
Maybe moved to somewhere else. But we still wanted to keep it, so it's now in an appendix. But be it in the latest published version, it's still present in the main text.
Aha, so you're not working on the master branch. I'm looking at the wrong branch.
No, we have to.
We have
V04.
V04, yeah.
Ah, sorry. Okay, so I was reading in the GitHub, but on the wrong branch. Okay.
The idea is to choose an approach only anyway. So for the editing phase, we still have multi-ETag in an appendix, but it will go away. Basically, we really stick to ETag in the body.
So okay. So but this group ETag, will that remain?
That has been moved to GroupCon proxy.
Ah, of course.
And same for the big caching model for the proxy. All moved out.
That goes together, and yeah.
Okay, good. Which version was John reviewing now? Was the version the latest published version, or?
Yes.
Yeah. Okay. Thank you.
Yeah. Just a brief question to confirm, because I didn't find it quickly in the pointed to document. That server ID that the server picks does not necessarily have any particular structure inside the E-tag. So the E-tag is still an opaque option, but the server kind of phrases its E-tag in a way that it's unlikely to collide with any other server's E-tag, right?
Yeah, that's right. So maybe this text what I have here is not entirely correct. So it's not even about embedding necessarily.
So it could, for example, be kind of form the hash over your own identity and the content, and then truncate this to so and so much, and that would do just the same thing.
Yeah, that can be the same. So it's not in that case not embedded, but it's still used to create it. So with some probability, it will be unique to that server. Yeah.
Thank you.
And indeed, there's a choice like an application choice, so you can make very long E-tags, which is, of course, more likely to be unique, but it leads to more bytes over the wire, or you could have short ones. You can make a trade-off there, just like for the normal E-tag. Okay.
So it seems good to consider this adaptation of ETag.
Yeah, it's basically the same tag option with some new usage considerations added. So when it's allowed and then not. Also the content, yeah.
Okay.
Okay, if anyone thinks about other options that we need to explore, then I think that's open for discussion. So to give you of time, Marco, how we do? We should first conclude this.
We have one more slide only, I think.
Yeah, one more slide. Yeah, and that's the next steps. Yeah, so addressing the comments from the review that John did. Steps. So for that, we created GitHub issues with tasks to do. Also, the other GitHub points are being worked on. And specifically, this last discussion, so to decide now on the validation method between client and origin service. So there we already propose ETag. But yeah, I think we should also give that a chance to be discussed at the mailing list if people want to say something about that. Then finally, to submit version 4 based on this editor's copy before the ITF meeting cuts off. Yeah, and that's it for this round. Thank you.
Thank you, Esko. Any more questions, comments, anyone?
I'm thinking about a little bit about the John's input here on the denial of service aspects and so on. We have this unsecure mode of co-op, this no-sec mode, and we are in this document. It's being there is also a no-sec version. What is the reason for having the no-sec? Except that, I mean, if we would design co-op today, would we really allow the no-sec mode?
That's a good question for the designing today.
I mean, we know there are misuse of co-op and denial of service attacks has been executed already, and I just wonder why we want. I mean, I understand from point of view that we want things that work in with co-op should work with group co-op as well. But I just wonder that if there would be a version 2 of co-op, then I would ask the same question. Why do we have a no security mode?
Yeah, I think we do say something about the forms of authentication. So I think it's mentioned somewhere that the server must be able to authenticate the request. If it's not using security, then there must be some other way to authenticate. That's probably by deployment then, that it's maybe deployed in some isolated network. All the hosts that are on that network.
Yeah. Yes.
Might be isolated. Might also be secured by some layer that we don't, as co-op users, we don't see, like layer 2 encryption, something, or even IPsec. Although that doesn't count as literally no sec, but it behaves like that for group com purposes.
Yeah, I mean I think that's reasonable, but why wouldn't, if you want to apply group combits like that, surely you could do that. But why do we in the specification write that there is a no-sec mode? Why do we allow it? I mean, people may deviate from specifications if they know. If it's an isolated network, what does it matter if they deviate from? Or maybe I'm. Yeah. I just want this to be clear on. I mean, sometimes we write things you must not do this, and then you still in the appendix say that, well, there are circumstances when this could happen. But in the body we actually stress that you should not, or you must not use yeah.
Yeah, it's still really not recommended, of course, unless you really know what you're doing. You may have some situations where you still don't have too much of a choice, like very initial discovery.
Okay, could you elaborate on that?
Discovery of services or resources, I think it's mentioned in the document already, otherwise we should. You don't have anything yet, like any kind of security association to use.
I don't think is that good enough reason? I mean, those are the things that you can exploit for getting amplification attacks or multiplication attacks. Why would that be?
I think it might be worth pointing out here that not all cases of multicast do result in exploitable amplification. So, for example, if we're looking in that case of early discovery, at cases where a device is looking for its group manager or for a resource directory to join initially, then there is only one on the network. There will be only one or maybe two, but not an exploitable number of group managers or resource directories. But still, the device doesn't know and uses the multicast address a bit in the sense of an anycast address, but technically it's a multicast because it's going out to all the devices because there is not enough information to find the device that it's looking for. So, for example, for finding a group manager or a resource directory, there is no aspect of amplification unless there is a great number of those devices deployed, in which case these have to coordinate anyway. And then some of them can decide not to join the group, but to kind of negotiate which of the ones is the one that kind of responds first, and the others are just fallback failure robots or not.
Okay. Yeah, but I think that would make more sense to sort of be more quantitative in the sense of what can happen when you send out a group request, because that's not really clear. I mean, currently it's only a high-level statement, I think. Just saying that it's for sensitive and mission-critical applications not recommended to deploy in no-sec mode. And that's not, I mean, the problem is not only for the particular application, the problem is for all other applications that might be inflicted. But
yeah, I think this was John's point.
Okay.
Adding these points that are missing now through, and they should be covered.
Okay, then I'm just repeating that. Sorry.
Well,
okay.
There's a difference, of course. So John was mentioning that even with group or score security, yeah, we still have issues left. Basically, we're now talking about no-sec mode used for discovery. That's because it's discovery. We typically have, by definition, no security context to start with. Find out, for example, find your group manager and deployment, or find another node that offers certain services. But that's a bit of the problem. So there you cannot apply a group score solution. Because you don't have any security context to start with. It's see it's a different case in a sense. So it would still more easily run into this application problem, of course, with no sec. So that means if you query like you send a query like, okay, give me anyone with any co-op services, and you could expect a lot of responses back, of course.
Yeah, no, maybe you're right that there is. I mean, there are settings where this is actually useful, but it must be clear then that when you design those, that you can't use them for sending any messages. Sort of that you shouldn't be able to trigger that somehow from. and also make that be sent sort of like a multiplication effect. Yeah, okay. I don't know what else to say here. I just thought that this is something that should consider.
Yeah, well, we do mention in the current text that discovery is a particular use case where no SEC is applied.
Yeah, I noted
for
that.
devices, yeah, they do not have the security context yet. Yeah, in a way, it makes sense to limit those cases. Yeah? So it's okay if you're just using multicast to discover a single particular group manager or resource directory, for example. Yeah, it's better than if you start discovering and give me all devices with any co-op service, so hundreds of responses then in that case. So you can design it in a good way and then a bad way, of course.
Maybe that's a security consideration then to add to sort of that you try to restrict the cases where no SEC works.
Yeah, exactly.
So the scope and the type of traffic should be narrow, specialized also to be sure that you end up targeting a few possible amplification vectors in the first place.
Yeah, something like that.
Yeah. Sounds good.
It might be worth pointing out here that the general recommendation is not just to join a group because you know that because you can do multicast, but because you're actually configured to do so.
Yeah.
Please include it in the minutes.
Okay. Thanks for the discussion.
Okay, then we can move to the other document. I'll give an update here mostly on the status of the editing, and then we have also some open points, mostly on reverse proxies and improvement for those that ESCO can also cover. So as a recap, group combase is of course defining how a group communication setup can use proxies, either forward or reverse proxies, but it's keeping it at a high level and leaving instead the mechanics and the details for some other specifications, still highlighting the issues that one has to handle in that case. And this group.com proxy document instead is defining a specific mechanics to address those issues. And it's especially about a signaling protocol between the client and the proxy through two new COP options. So actually the origin servers don't really care and behave as usual. So we covered the forward proxies as main case, but also reverse proxies. And part of the content transferring that ESCO mentioned before involved especially the overall response caching model for the proxy that has now been moved into this document. The important thing here is that proxies, other than a good configuration on their side, are also required to clearly identify a client that wants to send a request out to a group, which implies client and proxy need to have a kind of security association that opens interesting things for later. So quickly how it works with the two options. Well, the client prepares a request to be forwarded to the group of server, and this is technically a unicast request to the proxy, right? Just indicating how to continue with the forwarding. As part of the signaling protocol, the client also includes this new option, multicast signaling. So confirming to the proxy that the client knows what it's doing and what it wants. And the option also has a time indication to tell the proxy for how long to collect responses to be forwarded back to the client. And the proxy will remove this option before forwarding the request to the servers. So nothing really changes for the servers. Server can send back a response to be forwarded, and as the proxy receives one of those responses, It includes a new option, response forwarding, and it specifies in the option basically the addressing information of the server. So when the client starts collecting these responses, it can, first of all, distinguish the responses from one another, and it knows which exact server produces which response. And that has the further advantage that later on the client can individually go and talk to that server, again through the proxy or bypassing the proxy if the network setup allows for that. We take as baseline the non-secure setup, at least end-to-end, but of course, pretty seamlessly, you can use GrupoScore to have end-to-end security between client and servers. As we mentioned, we need also security association between client and proxy, and that can be achieved through OSCORE or DTLS, for instance. But I have more on that later when it comes to OSCORE. So what we've done, as mentioned in the previous presentation, a lot of content was moved here. The general caching model for the proxy, and the response revalidation exactly between the client and the proxy. So above other points, these 2 points were before in-group conbis reasons to update RFC 7252, and having moved them here, they are making this document also eligible to update the core specification. And like group conbis was doing, in fact, before this transferring, the caching and the proxy is possible also in the presence of end-to-end security with GrupoScore, and that's also discussed at the high level, but pointing at the separate document on cacheable score for the technical solution to achieve that. So all of this with improvement compared to the original text of group conbis is also in the editor's copy in my GitLab repo in branch v04 for now. Okay, and for the caching model, the proxy that again was transferred here, this roughly works, and this has no big changes from what was in group conbis already at the previous ITF meeting. The proxy has a number of individual cache entries related to a resource, one for each server. So basically, a response from one server is used to populate the corresponding individual cache entry, which will be matched by a unicast request sent by the client as intended for that server alone. And this type of cache entry is such that as soon as it is populated, it is also ready to be accessed by a client. And then there is an aggregated cache entry that, in a sense, covers the whole group of servers, where the responses to a group request coming from any server in the group are kept. And it can possibly be up to date by a response coming from one server in the group, but as a reply to a request intended only for that server too, which makes it interesting how you update the overall lifetime of the aggregated cache entry. This is documented too at the moment. And a hit to this aggregated cache entry is possibly produced by a request instead intended to the whole group in the first place. So this is the model. And
may I briefly here?
Sure.
Could you go back a slide?
Yes.
Now that the freshness model of the other document says that you can only have a cached response if you know all the members of the group, isn't that aggregate cached entry now replaced with the knowledge of what the group is, so you can have kind of an individual cache entry for each of them, and then it's fine, or you do not, and then you have to send out anyway?
Maybe. I was covering that point in the following slide and building on your comment from Summit. No worries. I think so. Anyway, you had comments around ITF 110 and on GitHub for group conbis also about this point. But the easy one is the first one. Basically, it's something we wanted to do all along, but it wasn't clear enough in the text. And the proxy is indeed supposed to forward back responses as they come, and possibly update the aggregated cache entry only when the indicated time interval indicated by the client expires and all responses are supposed to have come. And that's when the entry is also updated. And the second point is instead what you've mentioned now. I think you've suggested to start with caching at the client that we did in group this, like Esther showed, and then you mentioned, okay, something similar should happen also for the aggregated cache entry, but perhaps something more can be done. And at least in the editor's copy, we sketch something like that. You can think of a proxy that has a lot of knowledge in real time, almost of the group. For instance, if it sits on a multicast router and can see new members joining the co-op group. And that's the best thing, because you'd be able to produce a very reliable aggregated cache entry and possibly invalidate or refresh it as it sees a new server entering. The next best thing, but not as good, would be that the proxy has more knowledge of the application or network context, like how long it take for a new server to join the group, and how much uncertainty time is tolerable for the client to live with an aggregated cache entry that is not 100% aligned with the current group membership. And as long as you stay within this, you can still be fine. But lacking any of this knowledge or acceptable enough knowledge, sure, then it's just better to not even have this entry.
So what are the options you are discussing now? Is it that we don't need the aggregated, or is it that it's?
I think Christian was opening even for forgetting about it.
Yeah.
Before, right now, it's defined with this kind of say rules, because the early conclusion was we need rules on the best way to handle it, and the impression was that under some hypotheses it can work well, and if the hypotheses are not met, just better to not have it, which is what you're trying to describe now.
Yeah. Yeah, I think that makes sense.
Yeah, I think this will need a bit of alignment with the other document, because
yeah,
kind of now that we have the statement in the other document, this can the practical implications would still be the same, because the proxy might know that, hey, devices only join, say, at midnight or every 5 minutes, and then we're back to practically this, but it can be phrased in a more precise way.
Yeah, I mean, a more aggressive wordsmithing would be just saying here exactly what group combase says for the origin client. This is trying to give more opportunities to the proxy, because probably knows better. So if you can have a look also at the text, the way it is phrased in the editor's copy of group proxy, in case we can get back to it and make it even simpler.
Yeah, still I was thinking it would be good to have a bit more detailed use cases here. So when would the proxy keep those aggregated entries? So at least one I recognize that if it's located on a router, that it's also handling multicast routing and handling maybe the registrations to these multicast groups. Yeah, then you can assume basically you can see all the servers as they join the group.
Yeah, that's a low-hanging fruit.
Yeah, exactly. So it would be good in this draft to have maybe explicitly explain those kind of typical use cases. And then this, the second bullet, this was the 5-minute example. So if proxy only knows that group members can only join 5 minutes or every day, or if it knows that for the application you can ignore the servers that joined in the last 10 minutes, you can say something like that as well. I think if you consider reverse proxies, for example, you can have some application knowledge encoded in them. But you can also have rules saying, okay, yeah, anyone who joined in the past 10 minutes, it doesn't count yet. I can still do my caching. It's possible. It's possible, but then, yeah, still it's question doesn't then know all its members, and doesn't know that it has a response from all of them. Because there could be one group member that has joined 10 days ago, but that, yeah, still didn't get the chance to receive the request.
Right. I think, by the way, you listed those use cases, as you call them, for the origin client in group combis, so we can bring them in here.
Maybe I have now clearer words for what I was clumsily trying to say before. I think that we should aim for a proxy to be just a server tagged to a client. So whatever we have in application rules that a proxy could know of should also be reflected in client rules if the proxy if we're not talking about a proxy but a client that is caching. So I think we should try to avoid having special rules that apply to proxies that don't work just as well also for the client caching case. And if we need something better, then you can have out-of-band knowledge of where the router is, of which members may or may not have joined, then maybe this should better be in group combis, and here just kind of pointing towards that.
So what we can have for the proxy is, well, other than the proxy knows everything, because, for instance, it sits on the router, or it has to have context knowledge like any possible other client to be on the safe side. Right, otherwise just better to not have this in the opposite case.
I think the point was whatever you can move to the client's requirements in this, then you better put it there if it applies to both client in general and to proxies. That's something to consider then. What should fit where. There are some proxy types that, like some forward proxies, for example, that have any application-specific knowledge. So that's, yeah, it's also client, but but of course sort of dumb client in that case.
Okay, so it will most likely build on the requirements that were included in group combis already with the last additions.
Yeah, in that case, if it's dumb client or doesn't know context, then yeah, it basically means just send it out always in the request. Yeah.
Okay, then we can align the two documents more on this.
Yeah, also in group combis, I did not basically introduce the aggregate hash entry because it so far didn't seem necessary. But the client itself could also keep something like an aggregate hash entry.
Yeah, it's probably an overkill for group combis. It starts being useful more here.
Right. Yeah. It's for the validation, so from the client.
Yeah.
Thing is, the aggregate entry is nothing more than a pointer to the cached states we have. So if now that the requirement has come in from the client side, or maybe we can reshape it, but in some way the client knows what the servers are, which servers are there expected to be, then the aggregate kind of state vanishes into something that has no state, because we know somewhere else what members are there, and we know in the cache what their individual contents are. So there is no aggregate cache in that sense anymore, because there is this knowledge somewhere else, explicit or implicit, about which members are there in the group.
Okay, something I need to think about.
So that will mean that the group request from the client who's just hit the multiple cache entries at the proxy then.
Yeah.
Yeah. So it's more a matter of phrasing. Okay, thank you. Right.
So sorry, what was the conclusion here? Was it that you're reconsidering this aggregated, whether it's needed or not?
For the matter of phrasing, it's probably easier to just not consider an explicit aggregated cache entry, but thinking instead of a group request from a client may hit all the individual already existing cache entries at the proxy, because a client friendly to this would have already a knowledge of the whole set of servers in the group anyway, if I got Christian correctly.
Yep.
Okay.
So the functionality is interesting to have under some hypothesis. It can be presented in a more efficient way.
Mm. Okay.
Thank you. Yeah, and there it comes to reverse proxies that we are already defining, and we have some examples about as appendix. But ESCO noted some possible improvements also for the examples. So I think it's certainly better if you cover this slide, ESCO.
Yeah, okay, that's fine. Yeah, so this issue is on reverse proxies. So one of them was basically to add an example of a reverse proxy, how it looks like using URI templates. And that is something that is then taken from the RFC 8075. So this talks about HTTP to co-op proxies. And it defines a nice way of encoding a co-op request in a URI, URI that's included in a request to the proxy. There's an example here in the second bullet just to show that. So in this case, it's not a HTTP proxy, but it's by default a co-op proxy. So it's a co-op S access on DTLS, myproxy.example.com. And it has a resource, that's /p. That's the resource that offers the proxy functionality. And through the proxy, now the client wants to access a specific group. So that's group 3.example.net. That's co-op group. And of that group, it wants to access the resource light example to do a GET request there. Now the URI that can be used to the proxy is shown there in the line below it. So it has the light blue co-op S. So you see that basically the co-op URI is just appended to the URI that's used to access the proxy resource. This is one of the default ways to encode such a request using a URI template, so defined in the RFC. So the RFC defines also various other methods, also customizable templates, so that can all be done. Also for the co-op to co-op proxy case, and also for in this case co-op to co-op group proxy. I listed also some alternatives here. So there's the light green line and the purple line, and that's for reference. That's how to do it by an HTTP proxy. It's also going through another resource /HC. So this is just an example, and that's basically something that will be nice to be added to the existing reverse proxy example that we have, because it uses a completely different URI structure. Yeah, different implementation. And we had some questions on these reverse proxies specifically. They're listed here in the slides. So one question is, can the multicast signaling option be received by a reverse proxy and then also used. So it uses the, for example, the timeout there to time the group request. We assume the answer is yes. It's not necessarily a forward proxy that can do. In principle, a reverse proxy can also do that. And second question was, can the response forwarding option be used also by a reverse proxy? And there we assume in a similar way that the answer is yes. So if that proxy wants to send response forwarding options, it can decide to do that. And it can even be, we think it can be even independent from whether or not the multicast signaling option was used. It would be useful to allow that at least. And that's because the option is elective. It means that a client that doesn't know anything about these signaling options gets the response forwarding option, can safely ignore it, and that's what its co-op implementation will also do in that case. There's no harm done. And the reason we put these questions out is because, often a reverse proxy is also kind of proxy where the client is not even aware that it is a proxy, so it behaves like an origin server. That's why we ask these specific questions. Of course, client can, in this case, detect, hey, I'm talking to a reverse proxy because it gets multiple responses back. So that's the telltale sign that it's not like a normal unicast server serving the resource.
Do you think that a proxy should have leisure to return multiple options, even if the client didn't send response forwarding the response forwarding option?
In this case, I was thinking for reverse proxy can do that, yes. And the reason is actually that reverse proxy is encoded with often some application level knowledge.
Yeah, but the client would not. So the client would be I think the client would be at least confused by several response returning, and in some protocols even terminate the protocol because it's kind of receiving nonsense. So I
think we discussed it before. So one assumption is that you have a client that is accessing this proxy. It must at least be aware at some level that it's accessing proxy and that it's accessing a group resource, especially if you look at the example above.
Yeah.
So that's very clear that the client knows what he's doing. He's even encoding specific URI.
Not necessarily. So the thing is that reverse proxy URI might have been passed to the client by some other party. So for example, there might be a DIN link pointing to that resource, and the client has no idea that there is kind of this thing in there is a URI on its own.
I see.
So what I think should happen, personally, is that if the request comes in with if the thing encoded in the reverse proxy URI is a multicast address and there is no multicast signaling request, then kind of there might be option. I don't have kind of there can be various unique answers, but there should only be one. But if the client is aware that this is a multicast URI and it might have been told that so kind of in a side channel to the URI, then it would send a multicast signaling option, and then the server could forward the many responses. And if not, then it would be just the same case as if a regular proxy got a request for something that the proxy knew was a multicast address, but the client might not know. In which case, also I think we prefer not to send multiple requests, even though unless explicitly configured.
Yeah, okay. You're saying that basically the proxy can then maybe not execute a request, but even give back some error.
I think the kind of the options are the same as with the regular proxy. The kind of the easiest thing is to say, yeah, sorry, error. That's a request. That kind of request I can't process to the requested URI. It might also use some kind of application-specific aggregation. if that's a thing there, but kind of erring out would be the safe default. And if the client knows that this might be that there might be something that has multiple, that is multicast-ish behind that, it would just send a multicast signaling option and thus give the server leisure to respond with multiple options.
Okay, yeah, the way that's like safer solution. But I'm thinking
it's pretty much what we have in the examples now. So this was a possible study of a further step, but
yeah, okay, that's what we have currently. Yeah, so we need depending. Yeah, you need to depend on this signaling option. Yeah, I was thinking for the reverse proxy case, so that's something we don't discuss in detail yet. But we can actually say for the security reasons to meet the expectations of the client. Only serve this client if it includes the option. And do that. And I was thinking that maybe we need a specific option value for the reverse proxy case. Client may not know what is the time value. So
that might be explicitly configured as well, but probably any time is kind of a good start.
Yeah, I was thinking you can, as a client, also include the option without invoking a specific value. So
I think it's a uint option, so that would make the value 0.
Yeah, you could say, one example is 0, and meaning as okay, you figure out time. I don't know. But that only works in a reverse proxy case who can determine a sensible default. Or proxy doesn't
it might work in a forward case just as well, because the forward proxy at least knows that okay, this is a 6-LoWPAN network, so kind of what can or cannot be true.
Yeah, that's right. In that case, it's knowing well connectivity. It's possible.
And on the topic of whether the reverse proxy can send a reverse forwarding option in responses even without a multicast signaling, which would be the case if kind of for only one option. I think in theory, yes, but we should carefully evaluate this against other ways of this would be in effect introducing URI aliasing. Now this is okay because that's what a reverse proxy does. But this might need coordination with protocol negotiation.
So, sorry, you were saying about the case where no multicast signaling option is included in the request.
Yeah.
Then, but okay, if you have that, and we just discussed that, okay, maybe the proxy doesn't even execute the request. So the second question becomes irrelevant then.
Okay, that's what you meant by this, because I mean, this could just as well. The proxy, the address could just as well. I thought I understood this third point to indicate that if the request in there happens to be a unicast address, and a multicast signaling option may or may not have been added, then the proxy might still include that response forwarding option. And that would be basically like saying, yes, but by the way, my host name is actually. And that would need further consideration.
Yeah, okay, that's a different use case. I think in unicast had to say where did the response come from, like what's the origin. Now that is also useful to capture. I think you can think about that, but it's not. Yeah, I did not mean it in this way. So it was more related to group communication.
Yeah.
Okay, thank you. And I think we covered all the big things. We have just a few more heads up also track with issues. This is related to work ongoing in the core href document, where also the final details are hopefully converging. It's essentially a way to express URIs or CRIs in a compact way. And a proposal from Christian was to use this already in the multicast notification document, out of which we consider a subset in here in the response forwarding option to indicate the address of the server producing a response. So once those details are nailed down for CRI and we use that first of all in the multicast notification document, we can just as well do the same as we're doing now, but using this compact representation of addressing information. So it's just a heads up for something in the queue. And another open issue, I mentioned this at the beginning, we need a security association between client and proxy in a way or another for client identification. This, of course, can be DTLS in principle, but especially if you have Drupal score used end-to-end between client and servers, it's just more convenient, also from a code size point of view, to have instead OScore between client and proxy. This is something not really existing today. And currently, we still have an Appendix A in this document describing this only at a very high level. So the conclusion from ITF 110 was that this is only one of a few more use cases where something like this is needed. And anyway, it's some work that requires to have a bit more attention and consideration for proper analysis and design. So we agreed to take it out from this document and have it as a separate draft of which we are about to finalize a version 0. So after that, the plan is anyway to remove the Appendix A from this document, and so that this document can instead point to the new one about this feature. Other things left in the queue is to do whatever GroupCombis defines for response revalidation here on the leg between proxy and server. So thinking of the proxy as a client. So most likely we'll converge again to an adapted version of the simple ETag option. And then we still have the relatively old issue that keeps staying behind because more urgent things continue coming up about enabling this same mechanics and signaling protocol in case our proxy is an HTTP to CoAP proxy. And that ultimately would enable an HTTP client to talk through the proxy to a group of CoAP servers. So we had a rough idea how to do that. Other things just keep preempting, but it's in the queue. So we'll try to address as many open points as we have. Also, thanks to the feedback we got today, and submit a version 4 for the cutoff. In the meanwhile, more feedback or even reviews are welcome.
Thanks.
Thank you also for the very good feedback. So we are at 1:30, but I remember Christian mentioned any other business at the beginning of the meeting.
Just very briefly, I'd like to point out again, and the link is in the minutes, that I've started collecting some CoAP FAQ, which all probably don't have a place in a document if we don't resume any lightweight implementation guidance group. So if you have strong if things come up with users that you talk to again and again, or you just want to look at what is out there, what are questions that come up, especially if you have opinions that might kind of differ from what's in there, look there, start discussion, or just edit it, because it's a wiki and it's not supposed to be authoritative, but just contains a few kind of common pitfalls and things and patterns that emerge.
All right.
Sorry, Christian, what was the scope? In what sort of specifically?
Pretty general CoAP stuff. So there are things like, and there are also controversial questions, and there's like, do I have to send a URI host option or not? Which is to me the most common question I've heard about.
Yeah.
Or how do you do redirects? Why do you have plain text responses to errors when this is super wasteful on a constrained device? Things like that. How do I send incremental updates over an observation? You don't, but this is why.
Okay, thanks.
It's trying to capture what I think kind of emerges as things that you've come across when you've been on the core mailing list for some time, but newcomers might not kind of, you can't get it from the archive. You have to be part of the discussion or have someone digest that.
Could it also be semial material for the core clar document whenever it happens?
Quite possibly, yes.
Very good. Thanks for that, Christian. Okay, any other things you want to raise for today? No, then thank you all for your time and your feedback. Talk to you in 2 weeks.
Thank you.
Thank you.
Thank you very much. Bye-bye.
Thank you.
Bye.
Bye-bye.
And Marco, just a brief note. Sorry, there's a few points in the discussion where